math induction, we do the 3 steps. It sounds like a 3-step program for math induction. Something different. N equal to 1, N equal to K, N equal to K plus 1. All of these math inductions will be this way. So what we're doing is thinking of a ladder, and you want to climb the ladder to the top. And for a formula, you're trying to say, this formula works for anywhere on the ladder. Well, the formula would better work. If you're going to climb a ladder, what do you better be able to do? Take the first step. If you can't take the first step, then it's not going to work. So this formula better work for the very first N equal to 1. If it doesn't, it's off the books. And then what we want to do is we want to go anywhere K on this ladder and be able to do what? Take the next step. So that's the idea behind the weak math induction. Very cool. So let's see if this works. We're saying that this formula is divisible by 64 for all n greater than or equal to 1. So we're going to put in a 1 because it's greater than or equal to. The first one is 1. So 9 to the 1 plus 1 minus 8 times 1 minus 9 needs to be some multiple of 64. So 9 squared is 81 minus 8 minus 9 is 17. And of course, that is what? That is 64, right? Isn't it? Yeah. Is that a multiple of 64? Yeah. So then you write, therefore, true for n equal to 1. Very good. Love it. Next, we're going to look at n equal to k. Now, this is my assumption statement. This is going to be used later. We just change all the n's into k's, but this is going to be, we'll call this n times 64. Some multiple n times 64. Yeah, let's call it M2. This will be M1, which is 1. We'll call this one M2. All right, now, when I do the next step, what we're saying here is that if I went k plus 1 minus 8 times k plus 1 minus 9, you're going to get a new multiple times 64. We call it M3. After that M&M commercial you were talking about. Now all I can think about are M's. Okay, so we're saying that this is anywhere on the ladder. We're taking the next step. It also is a multiple of 64. We're assuming that this is a multiple of 64. Then this one's going to be a multiple of 64. So how I'm going to do this is the old way first. 9 to the k plus 2 minus 8k plus 8 minus 9. And let's see. I see that multiple of 64 is going to be 9 to the k plus 1. So how many 9 to the k plus 1s do I have? Nine of them. I'll go through this again. 2 to the 3 plus 1. Is that 2 to the third times 2 to the first? So how many 2 to the thirds do I have? 2 of them. How about 3 to the 3 plus 1? That's 3 to the third times 3 to the 1. Yep. We'll get the, thank you. So then 3 to the third plus times 3. So this is going to be how many 3 to the thirds? 3. So if I have 9 to the k plus 1 times 9 to the 1, how many 9 to the k plus 1s is that? There's your 9. Okay. So this will be, yeah, 8 times k minus 8 times 1. So we're going to use this up here that says 9 to the k plus 1 minus 8k minus 9. I'm going to have left over 8 times 9 to the k plus 1. And then what are we left with here? Minus 8 is a multiple of 64. I'm going to say old way because this is the way I don't want you to do it because it's a trap. You have 9 to the k plus 1 minus 8k minus 9. What is that equal to? It's a multiple of 64 plus 8 times 9 to the k plus 1 minus 8. What? Wouldn't this be great if these were 64s, but they're not. And so we've actually hit a dead end, and this does not work this way. This is what we would have done as of this fall. But I'm going to show you a different way to do this, and it's going to work. So erase all that and go to this point here. What is 9 to the k plus 1 equal to? Solve for that. What's that equal to? M2 times 64, then what? Plus 8k plus 9. Do you agree with that? Okay. So wherever I see this, I can replace it with that. How many 9 to the k plus 1s do I have? Ugh. 9 times 9 to the k plus 1 minus 8k minus 8 minus 9. And we're just going to keep this here. And we're going to replace this 9 to the k plus 1 with what? There you go. M2 times 64 plus 8k plus 9. So this here is the same as 9 times 9 to the k plus 1. I don't like my colors here aren't working in my favor here. So do you see how I switched that out? Okay, so now I have 9 times M2 times 64. Is that a multiple of 64? Oh, yeah. And then it's going to be plus 9 times 8k plus 9 times 9 minus 8k minus 17 equals M3 times 64. Yes. The 64, well, no, you don't. Because you've already shown that this term is divisible by 64. So this is going to be 9 times 64 times M2. And then I'm going to get, look at this. Are you ready to be happy? You ready? 72k minus 8k. What's that? Ha. And how about 81 minus 17? What do you think of that? 64. So you're ended up with 9 times 64 times M2 plus 64k plus 64. Is this divisible by 64? Yep. So you could, if you wanted to, you could say 64 times 9m2 plus k plus 1. And now you can say, therefore, true for n equal to k plus 1. A little bit different, but I just wanted to show that to you because it might pop up. So therefore, now the big therefore statement, you have to write this, since, and how many of you don't like to write in a math problem? Yeah, tough. No, I'm just kidding. I'm just kidding. But you have to do this. So, since true, that was mean, cruel. Since true for n equal to 1 and n equal to k plus 1, then true for all. Did I do anything tricky here? This writing? Make sure you write this down. I wrote, yeah, I just wrote what I did. I wrote this part. It was true at the beginning, true for n equal to 1. I wrote true for n equal to k. This is always the same. You just write that. True for those two. Then it's true for all n greater than or equal to 1 by any math induction. No, because the k, n equal to k was the assumption. We used it to prove n equal to k plus 1.